Hi and welcome to Geeks for Geeks. Today we would be doing the post contest analysis of GFG Weekly Coding Contest 95. So, if you talk about me, this time I really enjoyed the problem set because being a competitive programmer, this problem set, just a sec. So, being a competitive programmer, this problem set was quite akin to the coding round, or I can say the contest of code forces. Like it seemed more like a contest of code forces instead of just GFG Weekly Coding Contest. So, second in question of Baganstein, there was definitely something wrong with that. Hi Ankit, hi Vinay, hi Ankit, hi Vison. Okay, so we would wait for the next 1 or 2 minutes and then we would start right away. So on 1st of January, I think so. Yep. When I secondary test case 2 was wrong. Test case 2 was wrong only. Basically, if you just observe for the test for the second problem, maximize the minimum score. Maximize the minimum score. This is what is told. You don't need to maximize everything. Yes, it was kind of harder than the usual. Okay, so I think we are good to go. We can start off right now. Okay, so let's start with the very first problem. The first problem seemed to be like the gaps of the problem was, I on a scale of 1 to 100, I would rate this problem 15, the next problem as 55, and the last problem as 70, I think so. The last problems were hard enough, but the first problem, the gap between the first and the second problem is huge. Okay, so now in this problem, so is my screen visible? Let me just see. Please rate the hardness. Second question was not on binary search. Entire screen. Yep, I think I'm good to go. Or do I need this? This looks better. Now is this thing visible? I think so. Am I visible? Just quickly reply. Okay, fair enough. So now in this problem, we are given an array of n strings, and the string contains lowercase Latin. That is, we can say that the string consists of A to Z alphabets in the lowercase. Now, each string is defined between the number of consonants and with vowels. So, what are vowels? A, E, I, O, U. So basically, as in the number system, we have only odd and even. Either a number can be odd or either a number can be even. So in the same manner, either a number can be a consonant or either a number can be a vowel. So what we can do is we can find out the number of vowel in this, and then the size of the remaining one minus the vowels is the constants. So I can say number of vowels minus size minus the value of number of vowels. Okay, and the absolute difference of it would give me the power of, or I can say, what is this? The value. This would be the value. So number of vowels. So I can quickly find out the number of vowels by writing if statement. If this particular character is equals to A or E or I or O or U, subtract the size minus the number of vowels. This would give me this. Suppose I have n numbers. Okay, suppose what I want to say is, suppose I have 5, 4, 3, 2, 1. and this one is an odd number, this one is an odd number, this one is an odd number. So what I'm trying to say is that if I am told, suppose I know the number of odd values are 3. So if I want to take out the even values, what I would do is total numbers is 5 minus the number of odd values. The remaining one is 2. So if we take out all the odd values, we would be remained with the even values. So in the same manner, if we take out from the size, if we take out all the vowels, then we would left with constant consonants. So number of vowels, the difference between the number of vowels and the consonants would tell me the value of each string. This is how you can find out the value of each string, and you can simply do it. I think it is good to go. Mm, yes, absolute difference. Okay. No, difference refers to the absolute difference only. Like the difference bet suppose my height is 5 and your height is 4. So difference between my height and your height is 1. It is not told that who is small, who is large. I don't tell you that, tell me the difference in absolute value. So difference means that it is absolute value known. So see, I'm very customer centric. If there is a mistake from GFG side, I claim it. If there is a mistake from your side, I too say it. I'm just being honest. Okay, don't think that I'm trying to manipulate the words and say. But in most of the question where there is a difference mentioned, it is already known that the other person already knows that this is meant by absolute. Even if you didn't knew, you now know something. Okay, so now we can start off. Yes, basically you can hash out the values also. So I would just, because I am a lazy person, so what I would do is int in is equals to 0 and mx is equals to 0. Okay, now what I would do is basically int I is equals to 0, I is less than n, and I plus plus. So for a faster implementation, instead of writing a, e, I, o, u if statement again and again, either you can write here an array and use a for loop, or you can simply do, if you're good in copy pasting, being an SD, I'm very good at copy pasting, so I would be doing that. So cn is equals to 0. Okay, so now I would be iterating on the string itself. Okay, or for auto e dash a of I, we would be iterating on the string. Or let's find out the intermediate length also. Length is equals to a of I dot size itself, and then we would say for int j is equals to 0, j is less than l, and j plus plus, because we would need the size of that part. So now we would say if a of I dash j, okay, is equals to a, or so now a E I O U. Okay, A E I O U. Okay, if this is the scenario, then this would be, if this is the scenario, then this would be Cn plus plus. Okay, or else if A of I is equals to consonants, what it is asked, find the maximum value. You have to find the, both have the maximum value. Okay, so I can say string ans, string s, and then I would say string answer is equal to 0. Okay. So now the number, if it is a e I O U, then I would say it is a vowel, and vowel would get added up. After all this is done, the power of a string is answer is equals to max of answer, comma, the absolute value of the vowel minus L minus the value of G. Okay. And at this point, this is so it is written that we would get the maximum value. But it is written that if there is a tie, we need to return the first one. So if we need to return the first one, then we need to save this one. So I would say int p1 is equals to abs of this. Okay. Now if p1 is greater than ans, then only we would say answer is equals to t1 and s is equal to a of I. This is done. Now we would return s. If t1, okay, this one would be int. Okay, seems correct. Okay, now this would be good. Okay, it's done. So now tell me the point at which you are not able to understand. So present string, chrome tab, permutation, making valuable string. Okay. What are you? Someone is asking me how to make logic and apply that logic to code. Basically, you need to solve a lot of problems. By solving a lot of problems, you would acquire the skill of making observation and drawing out conclusion, and then you would be able to do it. Can we write a function to calculate the difference for bit clean code? Yes, absolutely, you can do that. But what you can do is, if you are solving problems on an online judge, make sure you submit the problem as fast as possible, because if the same person has submitted the problem at 5:10 and the next person has submitted the problem 5:11, then that person, even though he has a better clean code, he took time to make it clean, he would be ranked below the rank list. So in online judge, this matters. It was, should we move to the next? Yes. Okay, we would move to the next part. Stonebacks. Yep. So see, many of you have understood this question in a wrong way. Okay. So now let me just tell you. Okay. So now you are given an array. Okay. And you need to divide the array in three parts. Okay. And rearrangement is possible. So what are the constraints? The constraints are rearrangement is possible, the very first one. The next one is at least one element in each one. Okay. Now you need to rearrange the elements in such a way such that the minimum score is good enough. This is what is told. मतलब रीअरेंजमेंट के बाद जो सबसे वर्स्ट सिनेरियो होगा वो भी सबसे वो भी उसी को अच्छा करना है। रीअरेंजमेंट के बाद जो सबसे वर्स्ट सिनेरियो होगा उससे अच्छा करना है। After rearrangement, the worst scenario, we need to be good in that. So now we need to divide the elements in such a way. So it is told that if we divide the elements, if you take the from, okay, if the first element is 3 to 3, okay, the first element has 3 to 3, and the next 3 to 3, and the next one has 1 and then 5. Okay, so in the worst scenario, I would take 3. Okay, I would take 3, like I would take here 1, here I would take 3, and here I would take 5. So the value would be 2 plus 4. How it is? Like, see, first what I can do is if I divide in this scenario, I take 3 from the first part. Am I visible? Okay. Understood. From interview perspective, clean code matters, right? Yes, absolutely. Okay. So now it is told that, see, I just read out the question. See, here in this, we are told that we need to maximize the minimum score. Like, rearrangement should be possible, and one element should definitely be contained inside one basket. Fair enough. Now, what I want is, suppose I distribute the element in this fashion: 3, 5, 3, sorry, 3 to 3. Here I have 1, and here I have 5. Okay. Or suppose I take 3 as the first element, then 1 as the second element, and 5 as the last element. Okay. So W1 minus W2, that is 3 minus 1, the absolute value would be 2. And W2 minus W3, that is 1 minus 5 is equals to 4. The value is 6. Okay, this is the very first one. Now what can be the second scenario? The second scenario can be 2, 1 and 5. So the values would be 2 and 1, the value is 1, and 1 and 4, the value is 5 minus 1 is equals to 4. The value is 5. Okay, then what we can have 3. Yeah, so this is the maximum possible score if we have this kind of structure. Okay, this is the maximum possible score. Other than that, no maximum score is possible. Like if you see here, it is written that it can be shown that no other distribution would lead to smaller score. This one is wrong. Okay, because a smaller even if we distribute 3 to 3 and 5 1, 3 to 3 5 and 1, then we can take 3 from the first back, 1 from the second back, and 5, then we can have 6. And if we take 2 1 and 5, then we can have this kind of thing. How many of you agree to this, that this statement is wrong, that it needs to be said that no other distribution would lead to greater score? This one should be greater. This one should be rated score. Now the statement looks correct. What do you think? How many of you agree to this? Okay, let me just check. Do I have a good internet connection on or not? Let me just block this person. Okay, good enough. I have a good enough speed. Seems fine. Okay, so I think so. Now is it lagging? Can we take 5 minus 1, 5 minus plus 5 minus 7? Yep. So 3 minus 5, 5 minus 2 is equals to 7. Okay, so now you got this. Okay, so no. See, the problem statement has been a little bit poor on this. Why? Because what it's claimed is that this value, okay, we can't decrease this value. Okay, like we are taking out this difference. This is what you have to distribute such in the manner. Let's suppose the weight of that again. The score will be. So see, this score you can decide it by yourself. The score you can decide it by yourself, but this arrangement would be as worst as possible. Okay, this is not mentioned in the question. This score you can decide by yourself, but the arrangement would be as worse as possible. So it is told that in the worst arrangement, it can be told in this fashion. In the worst arrangement, find the best score. Okay. Second question was not well explained. How to decide the worst arrangement? How to decide the worst arrangement? This is the question. So the worst arrangement, yes, it was not properly told. So in the worst arrangement, you need to find the best score. Okay, this is what I have figured out from this question. This question is poorly explained by the problem setter of Geeks for Geeks. That this is not clear, to be honest. So I don't know what is happening with all this. So the worst arrangement would be that the elements are have a very less difference. The elements have very less difference. The worst arrangement is this. If the worst arrangement has very less difference, then I can say that it is nothing but the sorted form. Why? Because the given array contains positive elements. I would just show you at this point. See, the given array contains positive elements only. So the less difference is the sorted form, and sorted form is the positive one. So now it is in the sorted form, it has less difference, and it has the positive one. Okay, so basically this is what I have figured out from the problem. I too don't know if this explanation of mine is correct or not, because it might be a scenario that the question is wanting something different and I am explaining something different. Okay, it might be a scenario. This is what I have drawn out the test cases. After analyzing the test cases, this is what I have observed. It might be a scenario I am wrong, because okay, so if you think I am wrong, just don't blame me. Blame the problem setters. Blame the people who are intended for this. Don't directly put the blame on me, because minimum difference, because I'm not the problem setter. Let me be very clear. Okay, in the question, last statement says optimally distributed. Yep, but according to the test case, this is not that thing. Minimum difference within the bag or in the bag. Minimum difference, like you need to take W1 from the first bag, W2 from the second bag, and W3 from the third bag. And what you want is W1 minus W2, the absolute difference added with W2 minus W3 itself. Okay, this is what is given. Now, less difference. What do you mean by less difference? Less difference is that suppose W1. So in the worst arrangement, the person associated would try to keep this one and the difference of this one as low as possible. The person would try to keep this one and this one as well as this one as low as possible. So this one would also be lowered down. The difference between this and this is also lowered down. So W1 minus W2, I want to lower down this also. W2 minus W3, I want to lower down this also. But see, you would say that the first element would be, the first smallest element would be here, the next smallest element would be here, the third smallest element would be here. You could say this, but the problem is i can I can find in the worst arrangement, I need to find the best score. If I am to find the best score, I would take the value from here. I would take, like, from the first segment I would take the smallest value, and from the next segment I would take either this value or this value, and from the last segment I would take this value. That is why he needs to divide the elements accordingly. Like उसे एक sorted form में ही देना होगा. अगर अगर वो haphazard दे रहा है, तो मैं सिंपली उसको सॉर्ट करके पहला स्मॉलेस्ट एलिमेंट लूंगा, इसमें से कोई एक लूंगा एंड दिस वन एलिमेंट लूंगा. So even if he puts up the smallest element at this position, even if he puts the smallest element in this position, second smallest in this position, third smallest in this position, and all the other smaller elements are with him, all the other smaller elements are with him, all the other elements are with him. So I would simply okay, find the best worst arrangement. Okay, so I think I should skip this question. It should be mentioned take worst case. Okay, fair enough. So as everyone is not able to understand, I don't think that you should move forward with this question. Like no one is understanding and the problem statement is wrong. So I don't want to take the heat. So in the comments, make sure you raise up your issues so that it is raised up to the concerned authorities. Okay. Better skip this one. Yeah, I think I should skip up this one. Yep, I would skip this up. Okay. So now this problem is interesting, but this problem is little bit hard, but I found an easy solution to this. Okay. So I found an easy solution. So see, let us just observe this thing. What you need to do is you are given an array. Okay. Don't worry. So see, basically what you can do is you write it down in the comments so that I can talk to the team with reference to the comments. Because if I talk vaguely, it would seem that I have a personal grudge or something. Okay, fair enough. Now let us move forward to this one. So see, this problem is very interesting. What you need to do is, see, you have an array of n integers. Okay, you have an array of n integers and you need to make a permutation of 1 to 1. And what is the given operation? You need to take two index I and j. And it is not told that I can't be equal to j. So I can be equal to j. You need to take any I and j, any I and j. And it can be I is equals to j also, because it is not mentioned that I is not equal to j. This should be the condition. So I j के बराबर हो सकता है because explicitly mentioned नहीं. So you need to take up two values and both the values a of I, ai modulo x and aj modulo x, and this would be the new value of both of them. This would be the new value. Now you need to take out a permutation out of this. So we already have one here. Then to make the second value as 2, what we can do is 7 modulo 5 is equals to 2, which would make it 2. 7 modulo 5 would make it to 2. I can do that. So see, 7 can be converted to 1. 7 can be converted to 2. 7 can be converted to 1 by 7 modulo 6 is equals to 1. 7 modulo 5 is equals to 2. 7 modulo 4 is equals to 3. 7 modulo 3 is again equal to 1. Please remember this. Okay? Please remember this thing. So a number n can only be reduced till the value of n by 2. That is why this is 7 by 2. Okay, please remember this. 6, 5, 4, and then when we come to 3, 7 modulo 3 is again equal to 1. Let's take an even value also, because you would think that I am claiming something different. So 8 can be converted to 1. So 8 modulo 7 is equals to 1. 8 modulo 6 is equals to 2. 8 modulo 5 is equals to 3. 8 modulo 4 is equals to 0. Then 8 modulo 3 is again equal to 2. So we can only go till the value of n by 2. Please remember this. Okay. So now here, when we see the next test case, see, when we see the next test case, I saw that there is already one. Okay, fair enough. Then we have here as 5. So 5 can be reduced to 2. Okay, 5 modulo 3 is equals to 2. So 5 can be reduced to 2. Okay, then I want to reduce 4 to 3, but I can't reduce 4 to 3. Why? Because 4 modulo 0 is equals to 0, 4 modulo 1 is equals to 0, 4 modulo 2 is equals to 0, 4 modulo 3 is equals to 1, and 4 modulo 4 is equals to again 0. Okay, and 4 modulo 5 is again 4 modulo 5, 4 modulo 5 is again 4, then 4 modulo 6 is again 4, so 4 would be there, so we can only achieve 0, 1 and 4, nothing other than that. We can't achieve 3. Why? Because we have seen that we can only go till n by 2 minus 1, n by 2 minus 1, n by 2 minus 1. So it is seal value 7 by 2 is equals to 3.5. Let's consider it 4. So 4 minus 1 तक ही हम लोग आ सकते हैं. So in the same manner, 4 divided by 2 is equals to 2 minus 1. It is equal to 1. So 0 and 1 we can achieve. Other than that, we can't achieve. So this is a property that you need to understand. 0 till the value of n by 2 minus 1. We can only compress a given value to this. Other than that, we can also compress it to itself by doing modulo. Do I make sense to everyone? Just give me a quick one. Many have submitted second question successfully. There must be a solution, sir. So I saw all the submitted solution of this, but most of the code, if you see that they are just using hit and trial method, like they have commented a lot of things. Okay, I make sense now. Okay, so I found an easy solution to this. The easy solution is that if a particular number already lies in 1 to n, I would simply add to result. I would simply add to result. Okay, if a number is greater than n, what I would do is I would say that okay, this number is greater than n. If I can compress, I can compress it like, see, suppose I want 8 to be compressed to 3, I can do it in one operation. 8 to be compressed with 2, I can do it in one operation. So if it can be compressed, so I would just write here compressed. So if it can be compressed, then it can be done in one operation. If it can't be compressed, then at that point only I would say -1, because this number can't be decomposed. So the permutation of 1 to n can't be built. Okay, simple enough. So if I can compress, I can do it in one operation. If I can't compress, I can't do it. I would return -1. Else I would add it to the result. This much simple it is. If I can compress all the values, then I can achieve. See, the idea is very simple. If something is already compressed, okay. So see, if something is already compressed, we don't care about that. If we can compress the remaining values, then obviously the whole answer is we are able to achieve. But if any value we are not able to compress, then it would disturb the whole equation and we would return from that point only. So now I have just used these all properties and I have tried to solve up this problem. And for me, this seemed to be the most easiest one. Okay, so what I did was I made a vector of size v of size n plus 1, okay, to remember the values. Okay, and I would name it as F. I don't need this. Okay. And I also I'm also keeping a track of all the values which can't be compressed. Like the remaining values which can't be like the remaining values. So these all values. These all. Okay. Like the numbers which are greater than n. So greater than n. Okay. Greater than n. So I would say all the numbers greater than n. I would keep it in this. Okay. This is a frequency array. Now what I would do is I would traverse. For int I is equals to 0, I is less than n and I plus plus. I would say that I, if the particular a of I is less than equal to n and a of I is greater than 0, because we want the permutation from 1 to n. Okay. So if that value lies in the segment 1 to n, okay, then we would say that yes, this index is done. This index is done. Else, if this does not lie in this segment, then we would push it to greater than n, push back greater than n dot push back the value a of I. Okay, done. Now sort. Okay, sort a dot begin comma a dot end. Sorry, this one would be I would sort this greater than value, greater than n. I would sort all the remaining values. Now I have sorted it. Now I would say int j is equals to 0. Okay. Why j is equals to 0? Because see, the number of remaining operations are 1, 2, 3, 4. At each point, I would be returning this. So the number of operations. So here I can say, so see, now I would iterate on the remaining values of greater than n. So for all the values of greater than n. Okay. So for all the values of greater than n, okay, val, okay, for all the values of the greater than n, if f of val, okay, let's not take this, int j is equals to 0, and let's say for int I is equals to 1, I is less than equal to n, and I plus plus. Now I would try to find the values. Okay. If I already have that current number, if v of I is already present, okay, like here we are marking it now. Suppose 1 is already present. So why would we aim for 1? If 1 is already present, we would say continue. Okay. Do I make sense to everyone? Okay. Why are we not checking if a particular number is between 1 to n is achievable or not? We would check at this point. See, if a particular number is achievable or not, all those values would be this kind of values, like elements which are already less than equal to n. It is already there. Here we would check at this point. Here I would say if 2 multiplied by I plus 1 minus 1, if it is greater, if it is greater than n of j, okay, then we would return minus 1 at this point. Else we would simply do j plus plus. At the end we would just return j. And this should be good enough to go. and this is done. So if v of I, so this is f of I, sorry, frequency array. Okay, seems correct till this point. Segmentation fault. Are we doing some errors at this point? Like, let me see. V of n greater than n. Okay, f of I plus 1 less than n. If the current element is less than equal to n, and a of I is greater than 0, f of a of I greater than pushback. Okay, else we would simply push back that element, then we would simply sort the element, then we would go to this point. If f of I is true, then 2 multiplied by this, we would return -1 at this point. So segmentation fault, your output. Can anyone tell me the test? Yes, sir. Explain. Could you explain? Okay, just a sec. Let me just clarify this one. For and j, like, have I used j at any point? So we need to return an integer only. Sort greater than n. Okay, let me first explain you this. Okay, so see, we are just using this condition n by 2. That is why if we just multiply 2 at this side, that is 2 multiplied by n plus 1. That is what we are doing. 2 multiplied by I plus 1. Okay. If the current element is greater than temp of j, we would return -1. Somewhere we are just, why am I getting segmentation fault f of n plus 1? Is this pushback a of I? If any value is less than equal to n and it is also greater than 0, any mistake are you able to find? Because a can be very large and size of f of n minus 1. Sorry, didn't check the condition. Thanks for the info. Okay. No, n can be, no, n cannot be very large. It is 10 to the power, like n would be 10 to the power 5 only, and we can make an array of 10 to the power 5. So this shouldn't be the issue. Like, let me just refresh it. I think after refreshing it, it would work. Now let us submit this. Why am I getting this error for int vector int again, comma temp if I is, if I is less than n and not equal to I, then v of I, f of a of I true, else we would push back that current element, then sort from the small to the large. F of a of I is already present. 1 and 7. Let me just see the point at which I made a summation. Like my summation was this. Let me see if this summation is working or not. Okay, the same solution is working here, but that solution is not working here. Don't know the issue. Fair enough. This is the idea, the same idea. Okay, I don't know why that is not working. B of I else pushback. Okay, fair enough. Might be an issue with something else. So less than equal to n. No, everything is same as less than equal to n, less than equal to n. Everything is same. I think I mistyped it somewhere. No, less than n. Yes, less than equal to n. Don't know. I need to keep it and check it. Line number 49. What was line number 49? I don't know. Okay. So now tell me the point at which you are not able to understand. I would share the time. Permutation making. So size of the greater than. No, size of the greater than won't make any issues because the number of element this is the power 5, so it would be also good. Okay, last two. That one is already and we would move forward to and two already we would move forward to suppose I don't have 5. Suppose I don't have 5. Element C if I can't decompose a particular number to 5, then I would say, yes, this is not possible. If I can decompose, like see, if I want to decompose 8 to let's say 3. So 8, I want it to be 3. So I can simply do 8 modulo 5. Okay, 8 modulo 5 and it would make it to 3. Suppose I want to make it 2. So 8 modulo 6 would make it to 2 and this one would be done. We don't have any issues. Okay. So I think that is clear from my side. So any queries you have for the, like I would be waiting for the next 30 seconds. If you have any queries, you can ask me, else I would turn off the session. Thank you so much. After a long time, yeah, after a long time, like Ananvita is asking me, I was doing some recordings, was traveling places, so a lot of things. Okay, so if you were not able to do the next, that is the stone bags, make sure, is CP necessary to crack product based companies? No, CP is not necessary, but doing CP is considered as a good thing. Okay, so that was it from today. Thank you and have a nice day.